Alright, in this video we're going to be talking about integrals of the form sine to the power of 1x times cosine to the power of nx. So at first glance it might seem that this would be a fairly complicated integral, and you might think, oh, maybe I'm gonna have to do that thing where I just have to expand this in powers of cosine square or something like that. But I'll show you that this is actually a lot simpler than it looks. And in this case we're taking n as being either an odd or an even number, so any integer really. It could be negative as well, doesn't matter what we take, everything is going to work out. So what we do in this case is we do a simple substitution. We say u equals to cosine of x such that du becomes minus sine of x dx. And what we're going to do now is essentially just multiply the integral by minus on the inside just to make it equal to this. So we're going to have minus sine x cosine of to the power of nx dx. And because we just introduced a minus 1 here, we need to take the reciprocal of that, which is still 1 over 1, which is that, but we have a minus on the outside. So that balances that negative sign inside. And now we make the substitution. So this times that becomes du. And now we have cosine x, which is u. So we have minus integral of u to the power of n du, and now we can integrate this normally, so that becomes minus u to the power of n plus 1 over n plus 1 plus c. And now what we can do with that is actually quite interesting, because it now becomes a matter of just substituting back. So this is going to be cosine to the power of n plus 1 x over n plus 1. And let's not forget the negative sign in front, so we have a negative sign in there, plus c. So this is going to be your final answer. And you might be a little bit skeptical about this result, so what we can do is we can try and differentiate that, and we should get back to the original answer, which is not this one, but rather that one. So just multiply that through, and this is your original answer, the function you started with. So let's differentiate this. So you're going to have minus, so obviously you're going to have to use the chain rule here, because this is the same as saying cosine x to the power of n plus 1. So a chain rule tells you bring the power down, subtract 1, and then you multiply it by the derivative of the inside. So this is going to be n plus 1 times cosine to the power of n plus 1 of x. But actually we need to subtract 1 from the power, so that's going to be just n. And then we're going to multiply this by the derivative of the inside, which is minus sine. And of course we have to divide this by n plus 1. So this is going to cancel out with that, and this minus is going to go away with that one. And we're left with sine x times cosine to the power of nx. So if we look at the original function, yes, we got exactly the same thing. So that means this is correct. Now we can try a numerical example just to illustrate what's happening. Let's do something a little bit more interesting. Let's do 3x. And then we're going to multiply this by, let's do cosine to the power of 5 minus 2x. So let's just blend it up to make it a little bit more interesting. So in this case, actually this is a really interesting one, because in this case we can't really do that thing, because if we say, okay, u equals to cosine of minus 2x, and then du is going to be equal to, oh, we did something wrong here. This is going to be 2 sine of minus 2x dx. And if you notice, the argument is different, so it's not the same function. So we cannot really do this kind of thing. So this method only works for when the argument is exactly the same. So let's say it is also 3x. So every now and then you run into some limitations, but obviously we need to work with whatever we're given. So in this case, we have to make sure both functions have the same argument. Alright, so let's start with this. Let's say that u equals to cosine of 3x, should be an s. And then du is going to be minus 3 sine of 3x times dx. Now in here, the only thing we're missing to get this is the minus 3. So what we do is we multiply this by minus 3, and then we put a minus 3 on the outside to balance it out. So we're left with sine 3x, cosine to the power of 5 3x dx. And now we have this expression times that, that's du, and this is just u. So this becomes minus 1 over 3 times the integral of u to the power of 5 du. So now we're going to have minus 1 over 3 times u to the power of 6 over 6 plus some constant c. And now we put cosine 3x back in here. So this is going to be, this is minus 1 over 18 cosine to the power of 6 of 3x. And then we have the constant c. So this is going to be your answer for that particular problem. And you can verify this simply by differentiating the expression, and you should get back to this original function. Now, can you do this with a function that is the other way around? Let's say we have cosine of x times sine to the power of nx. Well, yeah, all you need to do, now the substitution is different. We take, since this is the higher power, we take the substitution u equals to sine x. And now we're going to have du is going to be equal to cosine of x dx. And in this case, we notice that we don't really need to change the sign. So this is going to be straight away u to the power of n times du. And then this is going to be u to the power of n plus 1 over n plus 1 plus c. And then we substitute this back, so that we get sine to the power of n plus 1 x over n plus 1 plus c. So this method works for whenever you have a power of sine to any power n times cosine, or when you have the function the other way around, so you have sine of x times cosine to the power of nx.